Hello dear students, this is Vishal sir. Today we are going to study second chapter from standard 9 NCERT syllabus. Is matter around us pure? Let's go through the lesson and read some main points. How do we judge whether milk, ghee, butter, salt, spice, mineral water or juice that we buy from the market are pure? Have you ever noticed the word pure written on the pack of these consumables? For a common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures, hence not pure. For example, milk is actually a mixture of water, fat, protein, etc. When a scientist says that something is pure, it means that all the constituent particles of that substance are same in the chemical nature. So dear students, purity according to the scientist is different than what a layman thinks. A scientist considers a substance to be pure when it consists of only a single type of particle. If the object is not pure, then it is a mixture. What is mixture? Mixtures are constituted by more than one kind of pure form of matter. We know that dissolved sodium chloride can be separated from water by the physical process of evaporation. However, sodium chloride is itself a pure substance and cannot be separated by physical properties into its chemical constituent. Similarly, sugar is a substance which contains only one kind of pure matter and its composition is the same throughout. Soft drink and soil are not single pure substance. Whatever the source of the pure substance may be, it will always have the same characteristic property. Therefore, we can say that a mixture contains more than one pure substance. So, sugar is pure, sodium chloride, that is salt, is also pure, but the soda water that we utilize or the sugar solution that we make at home is not pure. It is actually mixture. So, the matter can be distributed in two parts, pure substance and mixture. Pure substance are those substances which consist only of a single material or which cannot be separated further. Just for salt, it is a compound. For hydrogen, it is an element. Other part of matter is a mixture. Mixture is the mixture of two or more substances in different formats. A pure substance has a definite and constant composition like salt and sugar. The composition of pure substance doesn't vary. Here we are showing matter as a pure substance when it is an element or a compound. Element composed of single kind of atom, and chemist can't separate the component of compound at all. Compound is composed of two or more elements in a specific ratio. Water is a compound made up of two elements, hydrogen and oxygen. Chemist can't easily separate the components of the compound. They have to resort to some type of chemical reactions. For mixtures are physical combination of pure substance that have no definite or constant compositions. Composition of the mixture varies according to who prepares the mixture. Types of mixture. Depending upon the nature of the component that form a mixture, we can have different types of mixture. A mixture may be of two types, homogeneous and heterogeneous. Mixture having uniform composition and properties throughout is called homogeneous mixture. In simple words, it is called solution. Heterogeneous is a mixture of non-uniform form in composition and properties throughout. A mixture can be divided into two parts, heterogeneous and homogeneous. Heterogeneous mixture, you can see different parts of the mixture. Here is an example of the pizza where you can see different components in it. Liquids are unstable and will settle out, just like the oil in the water. Homogeneous mixture is a mixture where you cannot see the different parts of the mixture. Here, the water has been added with sugar or salt and you cannot see and you can just taste the water. So, it is a homogeneous mixture. You can taste from any part of the water and still it's taste the same. Liquids are stable and typically won't settle. Alloys are also homogeneous mixture. The coin is made up of alloys, metal mixtures. So, homogeneous mixture can have variable compositions but in a uniform manner. While in heterogeneous mixtures, it contains physically distinct parts and have non-uniform compositions. Let's learn about solutions. A solution is a homogeneous mixture of two or more substances. You can come across various types of solution in your daily life, just like lemonade, soda water, etc. All are examples of solutions. Usually we think of solution as a liquid that contains either solid, liquid or gas dissolved in it. But we can also have solid solution and gaseous solutions also. In a solution there is homogeneity at the particle level. So solution is a homogeneous mixture at the particle level. Lemonade tastes same throughout. This shows that particles of sugar or salt are evenly distributed in solution. A solution has two parts, solvent and solute. The component of the solution that dissolves the other component in it is called solvent. In the example of sugar solution, when sugar is added to water, water is the solvent because it dissolves sugar into it, and sugar is the solute. So there are two components in a solution, solvent and solute. Examples given in the textbook are the solution of sugar in water is a solid in liquid solution. Let's see the properties of the solution. A solution is a homogeneous mixture. The particles of the solution are smaller than 1 nanometer in diameter, so they cannot be seen with naked eye. So in a homogeneous mixture, in a solution, the particles that dissolved in the solvent are very minute, very minute, that are smaller than 1 nanometer, so it cannot be seen with naked eye, and because of very small particle size they cannot scatter a beam of light passing through the solution. So the scattering of light is not possible in this, and the path of light is not visible in a solution. The solute particle cannot be separated from the mixture by process of filtration. So simple process of separating is not possible for separating both the solute and the solvent. Therefore it is a stable solution. Concentration of the solution. So the solution concentration can be qualitatively described as dilute or concentrated. Dilute solutions have small amount of solute compared to solvent, and concentrated solution have a large amount of solute compared to solvent. In activity 2.2 we observed that group A and B obtained different shades of solution depending upon the amount of solute present in the solution. It can be called dilute, concentrated or saturated solution. Now what are these dilute, concentrated or saturated? Dilute and concentrated are comparative terms. Here let's see some examples. Let's understand the concentration of solution with this diagram. If you can see here, there are two tumblers which have the same volume of liquid, and in the volume of liquid you can see the atoms. On the left hand side you are having more atoms than on the right hand side. The left hand side number of atoms are more, so it is known as concentrated solution, and on the right hand side it has less number of atoms, so it is known as dilute solution. Now let's study for saturated and unsaturated solution. Activity 2.3. Take approximately 50 ml of water each in two separate beakers. Add salt in one beaker and sugar or barium chloride in the second beaker with continuous stirring. When no more solute can be dissolved, heat the contents of the beaker to raise the temperature by 5 degrees. Start adding the solute again. At any temperature, a solution that is dissolved as much solute as it is capable of dissolving is said to be saturated solution. So if on adding more salt to the water, if it doesn't dissolve, that means the salt solution is saturated. It cannot dissolve further salt. In other words, when no more solute can be dissolved in a solution at a given temperature is called a saturated solution. The amount of solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in the solution is less than the saturation level, it is called unsaturated. If you can keep on dissolving amount of salt or sugar in the water, the solution will be called unsaturated. What would happen if you were to take a saturated solution at a certain temperature and cool it slowly? We can infer from the above activity that different substances in a given solvent have different solubility at same temperature. The concentration of solution is the amount of solute present in a given amount of solution. So this is the definition of concentration. The concentration of the solution is the amount of solute present in a given amount of solution. And how can you find the amount of solute in the given solution? you can find by three methods. The first method is mass by mass percentage of solution. Here you have to find the you have to know the mass of solute and the ratio of mass of solution and its percentage. The second method is mass by volume percentage. So again the mass of the solute upon the volume of the solution 200 and the volume by volume percentage solution, that is volume of the solute upon volume of solution into 100. Now there are two more types of heterogeneous mixtures, suspension and colloidal. Now what is suspension and colloidal? A suspension is a heterogeneous mixture in which the solute particle do not dissolve but remain suspended throughout the bulk of the medium. So it may be the example of mud dissolved in water. If you dissolve mud in water, you can see all the type of particle flowing or scattered in water, and it won't dissolve in water, it will still remain like that. It will have husk, it will have dirt, it will have remains of plants and animals and everything. So that type of solution is called suspension solution, and the particles of suspension are visible by naked eye. Let's see the property. It is a heterogeneous mixture. Second, the particles of suspension can be seen by the naked eye. Third, the particle of suspension scatter a beam of light passing through it and make its path visible. Fourth, solute particles settle down when a suspension is left undisturbed, and that is a suspension is unstable. They can be separated from the mixture by a process of simple filtration. Then we still have one heterogeneous mixture, that is colloidal solution. Mixture obtained by group D in activity 2.2 is called colloid or colloidal solution. Particles of the colloid are uniformly spread throughout the solution. So particles of the colloid are uniformly spread throughout the solution due to the relatively smaller size of particle as compared to that of suspension. The mixture appears to be homogeneous. So it looks homogeneous, but it is not homogeneous. Just like ink is dissolved in water, you cannot separate ink from water easily, but still the particles of ink are visible in water and they are uniformly distributed in the whole part of the water. So that is a homogeneous mixture. But actually a colloidal solution is a heterogeneous mixture. For example, milk. Because of small size of colloidal particle, we cannot see them with naked eyes. But these particles can easily scatter a beam of light, visible light, as observed in activity 2.2. This scattering of beam of light is called Tyndall effect, after the name of the scientist who discovered the effect. Tyndall effect can also be observed when a fine beam of light enters the room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. Here you can see that the photograph of the Tyndall effect. The air that you can see from between the branches of the tree is a Tyndall effect. Tyndall effect can be observed when sunlight passes through the canopy of dense forest. In the forest, mist contains tiny droplets of water which act as a particle of colloid dispersed in air. Now let's see properties of colloid. A colloid is a heterogeneous mixture. It looks like a homogeneous, but it is a heterogeneous mixture. Size of the particle of the colloid is too small to be individually seen by the naked eye. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed, that is, colloid is quite stable. They cannot be separated from the mixture by the process of simple filtration. A special technique known as centrifugation can be used to separate the colloidal particles.